In this work, we focus on continuous collision avoidance using conservative advancement and harmonic potential fields. Common formulations only penalize collisions at discrete time steps. This requires either large margins or a dense time discretization, increasing the complexity of the optimization problem. Yet, setting a suitable safety distance is non-trivial, and collisions may still occur during the transition between two valid states. We introduce a computationally inexpensive continuous collision avoidance term in presence of static and moving obstacles. Our penalty can be used directly as either a cost or constraint in off-the-shelf nonlinear programming solvers. We evaluate our proposed penalty on a variety of scenarios and compare constraints based on harmonic potential fields with ones derived from contact normals. For further experiments and validations, please refer to our paper and supplementary material.